Okay, good morning, everybody, and welcome to our live stream lesson for pre-calculus 40S. Um, I also want to say happy Earth Day because today is an Earth Day for April 22nd. So um, today what we're going to do is we're going to jump into lesson number 7, looking at how to solve exponential equations. So when we look at exponential equations, so these are some of the tips that we can look at or think about. Um, so it says here, convert to same basis and combine if possible to solve with the same base technique. If you can't convert to the same base, use logarithm to solve. All of the things that we've learned so far in terms of exponential rules or loss of exponents, loss of logarithm, change of base, all of that will be used in terms of solving exponential equation. So let's take a look at example number 1. Example number 1 says solve the following exponential equations, round to 3 decimal places if it's needed or necessary. Now you look at this one in here, 3 to the exponent 2 minus 8x is going to equal to 9 to the exponent 3x plus 1. The great thing about this one in here, looking at the bases, is we can, sorry, we can write these two using the same base approach. So we can express as same base because this is base 3 and then this one is 9, base 9. We can write 9 as 3 squared, same base 3. Okay. So let's do that. So this is going to be 3 to the exponent 2 minus 8x. And instead of 9, I'm going to replace 9 as 3 squared. So 3 squared to the exponent 3x plus 1. Okay, as you can see, we've created the same base 3. And once we have the same base, for the left side to be equal to the right side, the exponents have to be the same. Now, okay, so that means through 2 minus 8x will equal to the 2 times 3x plus 1. We're going to apply the exponent rule here, the power law. So this is the same thing as 2 minus 8x is equals to 3 to the 2 times 3x plus 1. And so these two exponents are now going to be equal to each other. So therefore, 2 minus 8x has to equal to 2 times 3x plus 1. And this one just becomes super easy from here on in solving for x. So 2 minus 8x equals to, do the distributive property of multiplication. So that's 2 times 3x. It's going to be 6x. And then 2 times 1 is going to be 2. Okay, and we're going to put all the x's on one side and all of the numbers on the other. So that gives you, gives us 2. And then if I take the 2 to the other side, minus 2 equals to 6x. And if I take this negative 8x to the other side, it becomes positive 8x. I'm actually just going to go this way. So it's going to be 0 equals to 14x. So divide by 14, divided by 14. So x is equals to 0. So after all that calculation, the x there is 0. Okay. So if you're just joining us just now in our live stream lesson, uh, welcome to you. And if you have any questions, just type in um, type in something to our live chat so I can address that right away. Okay, so what I'm gonna do is my answer is x equals to 0. I'll do this for now. I'll do the checking. I'll check once, okay, because just to show you that they are going to be equal to each other. So we said x equals to 0. So if I replace 0 wherever I find x, it will see if we're going to get a same number on each side of the equation. So it becomes 3 to the exponent 2 minus 8 times 0. And then we can evaluate this one, see how it goes. So this is going to be 3 to the exponent 2, which is equal to 9. And then on this side, we're going to keep going, evaluate that 9. Okay, you can probably see that right now. That's going to give us 9 to the exponent. 3 times 0 is 0 plus 1 is 1. So that would give us 9. So 9 equals 9. So therefore, our answer of x equals to 0 is correct. Okay, so just a short, quick check there. Okay, we might not be able to do all the checks for all of these questions, but just an example of how you can check your answer. Okay, now let's take a look at this one. There's certainly a different way, a different approach that we can do with this one, but here's the thing. Can we express this with the same base? Here, base 4, this one is base 1. So is there even possibility that we can express that as the same base? Now, we know that 4 to the 0, exponent 0 will give us 1. So any base raised to the power of 0 will give us 1. So we can rewrite as same base 4. Okay, so we can go 4 to the exponent x minus 2, and then 1 can be written as 4 to the 0, because 4 to the 0 is 1. Now that they have the same base, what would be the exponent? Just looking at the exponent, x minus 2 equals to 0. So bring the 2 to the other side, so that becomes x equals to 2. That was an easy one. Okay, just because we were able to write that as the same base. We're going to explore in the next, I think the other side of the page here. We're going to explore some questions where we cannot write as the same base. So let's take a look at this one. This one, is 1 over 10 to the exponent 4x is equals to a million. Okay, so is there a way for us to write this as the same base? So we can rewrite as the same base 10, right? This is 10. So how can we write that as the same base 10? It's 1 divided by 10, so that means this is 10 to the negative 1 to the exponent 4x equals a million. Now a million is the same thing as 10 to the sixth. 10 to the sixth. Now that they have the same base, we can equate the exponent. So therefore it's negative 4x equals to 6, and divide both sides by negative 4. Divide both sides by negative 4. So negative 4 cancels. So x must be, well, we can reduce this to negative 3 halves. So negative 3 halves. Okay. So those are not so bad of a question because we were able to rewrite the equation using the same base. Okay. If you have any questions about anything, please let me know, and then I'll try to answer those questions. Okay. So now let's turn to the next page. Turn to the next page in here. This one is 55 equals 2 to the exponent x plus 1. This is a base 2, and then this is 55. Unfortunately, we can't write this as the same base. We can't express 55 as the same base 2. So there has to be a different way of doing this one here. Okay, so what we're going to do is we're going to take the logarithm of each side of the equation. So we're going to say this is going to be log 55 equals to the, it equals log of 2 exponent x plus 1. Okay, now that we've taken the logarithm of each sides of the equation, we can apply the logarithm rules or logarithm laws. Okay. So if you want to refresh our memory on the logarithm rules, okay, logarithm of m times n is equals to log of m plus log of n. Log of m divided by n is log of m minus log of n. And then log of m to the exponent n is equals to the n times log of m. So this is the one that we're going to use right away. So this exponent will be at the front. You can rewrite that. So log of 55 equals to x plus 1 times log of 2. Okay. Log of 2. So multiply it in. Log 55 equals to x times log of 2, x times log of 2 plus 1 times log of 2. Okay, so far so good. Now we want to isolate this x in here. So what we're going to do is we're going to have that on one side of the equation. So what I could do is I can bring this log of 2 to the other side. So this is going to be log 55 minus log of 2 equals to x log of 2. Okay. These two, log of 55 minus log of 2, we can simplify that to log of 55 divided by 2 equals to x times log 2. So 55 divided by 2, that's going to be 27.5 divided by log of 2. 55 divided by 2, so that's going to be 27.5 equals to x log of 2 divided by log of 2 on each side. So x, this is now canceled, that's canceled. Okay, we have to take our calculator and calculate that one. Okay, log, so locate where your logarithm is. So log of 27.5 divided by log of 2. And we're going to get like, a long string of decimals. So it says at the beginning of the lesson in here, if we need to round it off to 3 decimal places. So we're going to round it off to, okay, so this is approximately equal to 4.781. Okay, so rounding it off to 3 decimal places is 4.781. Okay, now I'm just going to do a quick check on this one here just to make sure that everything is good to go. So I'll do that in this page. So we're going to check our answer. Check. This is for letter D. 55 equals to 2 to the x plus 1. Remember the x we got is 4.781 approximately. So I'm going to do this is my left side of the equation is 55 and then the right side is 2 to the x plus 1. So 55, this is going to be 55. This is going to be 2 to the 4.781 plus 1. Okay. This is approximate. So let's do that. So this is really 2 to the exponent 5.781 approximately. So I'm going to do that right away. So 2 to the exponent of 5.781. We might not get exactly 55, just to let you know. Yeah, we didn't get exactly 55 because this 4.781 was rounded just to 3 decimal places. If we kept all of the decimals earlier, then we would get exactly 55. Okay, so just to show us. So this is approximately 54.986, which is approximately 55. Okay, so that one's still considered good. Okay, so I guess I'll post this online as well. Okay, so that's how you would approach solving exponential equation where the base cannot be written as the same base, cannot be rewritten as the same base. Okay, let's try this one here. Next one. Next one. 2 times 7 to the x minus 2 equals 100. Now, I just want to let you know before we get right on to this part in here, this exponent x minus 2 only applies to 7, not to 2. Okay, because there's a brackets there, so this exponent x minus 2 is only applied to 7, not to the base 2 here. So what we could do is we can actually simplify this a little bit. We can divide both sides by 2, so the 2 would cancel. We're left with 7 to the exponent x minus 2 equals to 50. Equals to 50. Now, looking at that one, still 7 and 50, we can't write them using the same exponent. So in this particular case, we would have to take the logarithm of each side of the equation. So let's do that. So we're going to go logarithm of 7 to the exponent x minus 2 equals to logarithm of 50. Log 50. Okay, now we're going to apply the logarithm law. So bringing this x minus 2 at the front. So that becomes just x minus 2 times logarithm of 7 equals log 50. Okay. Okay, awesome. So now we can do the expansion in here. Oops, sorry, can't see that one. Now you could do the expansion in here. So x minus 2 times logarithm 7. So multiply it in. It's x times logarithm of 7 minus 2 times logarithm of 7 equals to log 50. Okay, so you okay with that part? So we've multiplied this with log of 7 and multiplied the negative 2 with the log of 7 to get that. And then the right side still remains as logarithm of 50. Okay, so where the x variable is on this side, so what we're going to do is we're going to take this is just a number. We'll bring this to the other side of the equation. So let's go ahead and do that. So it becomes x equals, oops, forgot something. X times log of 7 equals log of 50. And if I bring this negative 2 log 7 to the other side, it becomes a positive 2 log 7. Okay. So now, this is what we got. Okay. I mean, we can go ahead and just divide by log of 7. That's possible. But what I'm going to do is I'm actually going to show you how we can just simplify this a little bit using the logarithm rules. Logarithm rules. Let's see, log of 50 plus 2 times log of 7. Okay, I can rewrite this and bring this now over there as an exponent for 7. So it's x log of 7 equals to log 50 plus log of 7 squared, which will give me 49. Okay. So x log 7 equals to, this is going to be log of 50. Now, because these two logarithms are added, we can combine that as log of 50 times 7 squared. So x log of 7 equals to, I'm just going to figure that out right away. So it's going to be 50 times 49. 50 times 49 equals to 2450, 2450. And then finally divided by log of 7. So x is equals to log of 2450 divided by log of 7. Then we can figure that out. Log, you can give it a try on your own. Divided by log of 7. We're going to get again, an approximate answer. We might have to round it off to 3 decimal places in here. Okay, so approximately 4.010. There's actually different approaches to this one in here. This is just one of the approach that I made, but there's certainly other possibilities here. Okay, so that's that. Now, these two examples that I made it all the same log base 10. Log base 10. Okay. Let's take a look at the next one. Let's see here. Again, we can't rewrite this as the same base. So what we could do is we could take the logarithm of each side of the equation. Log of 5 to the exponent 3x minus 1 equals to the log of 45 minus x to the minus x. Okay, and then what we're going to do, we're going to take this exponent and bring it to the front. So that becomes 3x minus 1 times log of 5. Okay, hope you're okay with that one. We're using the law of logarithm. And then we're going to take this negative x and we're going to bring it to the front, so it becomes negative x times log of 45. Okay. You're probably thinking of what our next step is. Okay, our next step is to multiply this in. So this becomes 3x times log of 5. And then this one here is negative log 5 equals to negative x log 45. Okay, so now we're going to take this over here. bring all the one with the x's on one side and now just the numbers on this side. So we got 3x log 5. And if I bring this to the other side, it becomes negative, nope, becomes plus x log 45 equals 2. I'm going to take this negative log of 5, negative log of 5 to the other side. So positive log of 5. Okay, what to do next? The x's, we can't really just combine these two because they're all different terms, right? So what we're going to do is we're going to factor out x from here. So let's just do that. We're going to go ahead and factor out x. So when we factor out x, we take out the x, we get x times 3 log 5 plus log of 45 equals 2 log of 5. Okay, log of 5. Let me zoom it out a bit so we can see the whole page here. There we go. Okay, well that's pretty good. We could go ahead and divide by all of these, but what we can do is we can simplify it a little bit using our laws of logarithm. So this 3, we can raise it up there. That becomes exponent 3 for log of 5. So that becomes x times log 5 cubed plus log of 45 equals to log of 5. Okay. Now, because these two are being added, so we're going to use the other logarithm rule. It's going to be, we can rewrite that, simplify that as log of 5 cubed times 45 equals to log 5. Okay, now let's just do that in here. So this is x log of, what's 5 cubed times 45? Let's do that. 5 cubed times 45, it's going to give me 5,625 equals to log 5. Now let's think we're ready. Divide by that. Log of 5,625. Log of 5,625. That cancels, so we're left with x is equal to, oops, gotta try that again. Log of 5 divided by the log of 5,625. And I got 0.186. Okay, so that's our answer. 3 decimal places. Okay, so that's done. Okay, I'll give you maybe a moment to kind of think about that. It's all these steps in here. We got 2 more questions to go, and as you can see, it's getting easier as we go. It's getting easier as we go on with this. Okay, let's go ahead and do this piece. Example number letter G. So 3 to the exponent negative 3x plus 1 equals to, okay, e to the negative x. Now e, it's Euler's number. It's approximately 2.7. So certainly we can't make these two bases the same. So what we could do is, now because this is a base e, we could actually use the natural logarithm. Okay, natural logarithm. So let's do that. Because this is base e, we're going to use natural logarithm. So take the natural logarithm of each side of the equation. And let's see, we're going to again apply the same laws of logarithm. The laws of logarithm applies to the natural logarithm. So take negative 3x plus 1, and it's going to be multiplied with natural log of 3. And then we're going to take this exponent negative x, and we're going to multiply it with natural log of e. Okay, so where are we at now? Now you're probably thinking, oh, I'm going to expand this. Okay, do the distributive property. So let's do that. So negative 3x times ln of 3, or natural log of 3, plus 1 times natural log of 3 is natural log of 3, and negative x. Now this is interesting. We can actually simplify this. Remember, the natural log is for base e. Let's think about this again. What natural log means, what exponent do I need to raise e, base e by, to get an e? So natural log of e, base e, is actually 1. That becomes negative x times 1. Okay, so this could be equal to 1. That's great. So what can we do? The only x that we have is this part. So bring natural log of 3 to the other side, and then this negative x, bring it to the other side of the equation. So negative 3x ln of 3 plus x, just plus x. And then bring this negative to negative natural log of 3. And we have x on these two terms, so we're going to factor the x out. So once we factor out the x, then we're going to get negative 3 natural log of 3 plus, if you factor out x from x, you're just going to get 1. So let's not forget the 1 there. Okay, so I'm going to go this way. What do we have? Now we could let's see if we can simplify this one here. This negative 3, we can write that using the laws of logarithm, and bring this negative 3 up where the 3 is. So it becomes x times natural log of 3 to the negative 3 plus 1 equals to negative natural log of 3. And these two, we can't really simplify that, so we'll just divide by natural log of 3 to the negative 3 plus 1, natural log of 3 to the negative 3 plus 1. Okay. Let's see. So negative natural log of 3, so that's the numerator, divided by, I have to divide by all of these denominator in here. So in that case, I have to put a bracket right there. So natural log of 3 to the exponent negative 3. Okay, I might have to put the, let's just try this for a second. See if we're going to get the same answer. Yeah. So I got 0.479. Okay. So if you're not, I'm just, because there's so much going on in here that we have to, you're not sure if you should put a brackets or not. Here's the other possibility. Here's the other possibility. You can take negative natural log of 3. Okay, so instead of doing this part in here, you can just take it from here. Okay, so negative ln of 3 divided by, I'm going to divide by all of these, so divide by negative 3 natural log of 3 plus 1. Let's see if we get the same answer. Yep, we're getting the same answer again. Okay, so there's a possibility there. So you can just take this and then divide it by all of that. Okay. We're on the very last one. Let's take a look at the last one. Again, you got the base 3 here. This one's a base 2. We can't make them the same. So let's just, this is going to be a big one. So take the logarithm of each side of the equation. So let's go ahead. Log of 5 times 3 to the exponent x plus 2 equals to log of 2x plus 1. Okay, so now that we have that, we're changing everything to logarithm. Take logarithm of each side of the equation. So what we're going to do is we're going to, now if you could see this part in here, this exponent x plus 2 is only applied to 3, not to 5, but just to 3. So because these two are multiplied, we can split them up. So that becomes logarithm of 5 plus log of 3 to the exponent x plus 2. Okay, so split those up into the sum of the logarithms. And then this part, we can take this exponent and bring it to the front of the logarithm of 2. So 2x plus 1 times, okay, all of that has to be multiplied by log 2. Okay, so that's that piece. Now we can expand this even more. So this is the reason why we've been talking about expanding and simplifying logarithms, because we're going to see it in this situation. So we can take the law of logarithm again and take the exponent x plus 2 and bring it at the front of logarithm of 3. So this is still logarithm of 5 plus x plus 2 times log of 3 is equals to 2x plus 1 times log 2. Okay, so as you can see, there are no more exponents up there, and all of the x's are down here, not as an exponent anymore. So you're probably thinking, okay, my next logical step is to apply the distributive property of multiplication. So multiplying it in. So let's do that. Log 5 plus x times log of 3. So x times log of 3 plus 2 times log of 3, and then 2 times log of 2, or sorry, 2x log of 2, and then 1 times log of 2. So it's 1 times log of 2. Okay, so the next step is to combine, to put the one with the x variables on one side of the equation and all of that doesn't have the x variable on the other side of the equation. I'm really running out of room here. So take this part, leave it there, and I'm going to take this one over there. So this becomes x log 3 minus 2 log 2 equals, so this x log of 3 right there. And if I take 2x log of 2 to the other side, it becomes negative. Now, I'm going to take the log of 5 and 2 log of 3 on the other side of the equation. So log 2 minus log 5 minus 2 log 3. Oh, this is a really big one. Did I miss something? I missed the x there. So now that we have these, we can factor out the x variable. Let's factor out the x variable. So we got an x. So we get log 3 minus 2 log 2 equals to all of these things. Now, what's happening in here is that this log of 2 is subtracted by log of 5 and again subtracted by 2 log of 3. So what we can do is we can simplify all of these stuff to log of 2. Because it's being subtracted, that means we have to divide by 5, and then we're going to divide by, oh, I'm jumping so much in here. And then this 2 goes right there, so 3 squared. Is that too much? Is that too much jumping around? Okay, I think I would simplify that. No, I think it's too much steps all at once. Let me do it one step at a time. Okay, so just in case you're watching this and you're like, what just happened? Okay, I'm going to go log 2 minus log 5. This 2 will be going up here to make it squared. So negative log 3 squared. Okay, now I'm going to go over here. This 2 will be over there, will become exponent 2. So x log 3 minus log 2 squared. Okay, now I'm doing it one thing at a time. Now going on this side, this is log of 2 minus log of 5 minus log of 3 squared. So we can rewrite this using the laws of logarithm. Log of 2 divided by 5. And because this is minus, so that means it's also being divided by 3 squared. So this is times 3 squared. All these steps. We're almost there. Okay, so I'm going to bring it up there. Now this part in here, as you can see, log of 3 minus log 2 squared, because these two are subtracted, we can write it as a log of 3 divided by 2 squared. Okay. Okay. I could just probably simplify this part in here. So it's x log of 3 3/4 equals to log of 4 over, that's going to be 45. So divide both sides by log of 3/4. Divide by log of 3/4. Log of 3/4. So that cancels, that cancels. So we're left with, oh my gosh. Oh, this one should be 2. So this is going to be log of 2 divided by 45 divided by log of 3/4. Log of 2 divided by 45 divided by log of 3/4. Okay, I think what I'm going to do is I need to put this in brackets because I'm not getting. Okay, let's try that again. I want to tell my calculator I want to take the logarithm of 2 divided by 45. Log of 2, brackets 2 divided by 45 divided by log of 3 divided by 4. And I got the answer of 10.822. Ooh, that's a really fun, long solution for that exponential equation. So there you have it. So I tried to squeeze everything in here. Now, I have a different way of solving this, like a different strategies in solving this. I think what I'm going to do is I'm going to attach it to the notes for today. So you can see that, hey, this is one way of solving things. And there's other ways of solving the same equation. So I'll put that on our notes today. So for meantime, for the rest of our class for today, we have this assignment here on page 243, all these questions. Do give them a try, and all those questions are going to be super, super helpful for you. If you haven't done some of the questions from the book prior to this, I encourage you to try them because skipping, there's so many skills that we've seen in here that are super important. Okay, so I'll leave that with you. Again, you can email me if there's any specific question in any of the questions that we've seen before. It doesn't matter if it's from lesson 1 up to lesson 7. And if you want me to go over something, let me know and I'll go over it with you. Or I will set up my Google Meet again, and if you want to give that one a try, you can do a conference with me through Google Meet, and then we can sort things out. Okay? So, anyways, I'll leave that with you for today. And if you have any questions, please do not be shy to ask. Okay? Well, have a great day, everybody, and thank you for watching, either watching it now or watching it later. Okay, have a great day, and I'll talk to you soon. Okay, bye bye.